Course 1 Math, Lesson 28 is called Angles. In math, geometry specifically, we have some terms you should get your math notes out to understand and take note of for the future. In geometry, a plane is a flat surface, okay? A plane is like a tabletop or a piece of paper that we draw lines on, and when you put two on the same plane, they're either going to be parallel, meaning that they'll never cross, that this distance between them will always be the same amount. This distance will always be the same, no matter how far down the lines we look. Or they're going to be intersecting. It's got to be one of those two categories. If it's intersecting, it could be one of these two situations, either perpendicular at a square angle, 90 degrees. So in your notes, you're writing like perpendicular and maybe you're drawing it out, intersecting lines with this box here, 90 degrees, right? Right angle. Okay? If it's not a perfect 90-degree angle, this is probably the more likely scenario, unless you were real careful how you drew them or whoever drew them. They're called oblique, meaning they could be not 90 degrees. Maybe this one's 25 and this one's 75. Those are not 90 degrees. Now that can't be. This needs to be a lot more than 75. This would be like 155, because these all have to measure up to 180 if this line is going to be straight. Intersecting or parallel must be one of the two. I was talking about angles here. This is a 155-degree angle here, meaning it's an obtuse angle. Obtuse is greater than 90 degrees, whereas an acute angle, less than 90, and we already said, what do we call this angle? That is 90, perfectly up and down, is a right angle, perpendicular angle. Right angle, we call them perpendicular lines. Don't call it a perpendicular angle. Do you know what a ray is? It's listed to the side here. A ray has an end point and continues in one direction without end. So a ray looks like this, and we used kind of two of them to show angles oftentimes. The vertex here is where they cross, and a ray originates at that vertex. Angles are named in a variety of ways. You can name it with one letter, and that would be by putting it next to the vertex here. You could also do it with three letters by putting a point on either side, maybe A and C, so we could call it angle ABC. You can also call it angle CBA. But why do you think I can call it angle ABC, angle CBA, angle B, but I couldn't call it angle BAC? Why would that be a no-go? Why do you think? Because the vertex needs to appear in the middle every time, so there's no confusion when naming an angle. If we draw a straight line, which is said to have 180 degrees according to your protractor, which is that half-moon looking tool, okay, looks something like that. You've got, this is used for measuring angles. According to this, it's 180 when you just get a straight line. Straight line. So if we want this to be 180, that means if you just stick a ray on top, that this plus this will have to be equal to 180. Angle 1, angle 2 must equal 180. They must be supplementary, because we know that all of it ends up being 180 degrees. Show right angles with this little box here. Good so far? I hope. Acute and obtuse we talked about. Example 1, finally, we've got 2 examples quick before lesson practice. By the way, when we use 3 letters to name an angle, it says here, the middle letter is the vertex. Remember that? Now they're finally getting to that. So we'll remember that. Name the acute angle. How could we name the less than 90 degree angle? Well, I see it right off the bat, right here, right? Now, how do I name it? Not QRM, not RMQ, not MQR, but has to be either QMR or RMQ or maybe angle M. But angle M, what's the issue with angle M? Why can't we just call it angle M in this case? Because it's next to another angle. They're supplementary together. And if I call it angle M, I might be talking about RMS. There's an angle RMS and there's an angle QMR. So angle M doesn't work so well on this one. Only use that when there's only maybe one angle. Fair? So acute QMR, obtuse, what's that mean again? RMS, SMR? Means it's going to measure more than 90 degrees if you use your protractor. In this figure now, it's a closed figure, it's a polygon. All right. What's angle D? It's a right angle. We know that because of the box and because of the directions saying it. Okay. Which other angle is right? Right here. Which angle is acute? Less than 90. Looks like angle A. Right here. Show a little arc there to see. Obtuse would be then B. And we've covered all of them. You add all that up, it should actually come to 360 degrees when it's a closed figure, I believe. All right. You could even use 2 pencils to approximate an acute angle, a right angle, and an obtuse angle for fun using your desk tools if you want. All right, what should we do for lesson practice? Looking here, simple enough. Let's do BEF. Thank you.